All right. So you all know me. I'm Jim, W6JCZ. I'm your vice president, at least for another month and a couple of days. And you can all find me at the candy store. Everyone has probably seen me at the candy store. And a little bit about what I did before getting into ham radio. This is somehow relevant to this conversation, to this presentation. When I was in college, I did computer science, and my capstone project was actually on artificial intelligence and machine learning. And pretty soon you'll realize how this fits in with this presentation and what goes on behind how this works. So how many of you have used a digital voice mode? We're talking, D-Star, DMR, probably recognize some of these. Some more esoteric ones, P25, that's what the police use here, the trunking system. NXDN, it's a Kenwood protocol often used by businesses, schools, things of that sort. Now, there's a problem with all these modes, and it's that they're all proprietary. And as hams, we often like to tinker. We like to play with things. We like to figure out what makes this device work. We like to make improvements to it. And the problem with all of these modes is you really can't do that legally. Now, there have been, I guess, alternatives, drop-in compatible replacements for some things like C4FM and DMR. If you have an MMDVM or OpenSpot or any of these hotspot devices, you're already seeing it in action. It's an open source reimplementation of these protocols. They kind of work, but there are certain things that that aren't compatible with the true C4FM or DMR systems. So enter FreeDV. It is open source, meaning you can freely modify it, you can freely integrate it into your products. If you wanted to make improvements to it, you can even download the source code. And if you understand C and Python, you can easily make improvements to it. You can fork it and make your own version of it with credit to the original writers, of course. But it's made by hams for hams. It's hacker friendly. They encourage you to get into the nitty gritty to work on it. It's not a black box. It's not a proprietary chip. And it's usable not just on VHF and UHF, but also HF. And we'll get into why in just a moment. But the secret sauce behind the most recent update to FreeDV, what makes it work so well, is a mode called the Radio Auto Encoder, or RADE for short. And it uses a machine learning algorithm that compresses the voice input for efficient transmission over RF. And in fact, it's so efficient that the white paper claims it can compress 8 kilohertz of audio bandwidth into just 1.5 kilohertz of RF. For comparison, your average single-sideband signal is around 2.6 kilohertz. And your average AM broadcast is 10 kilohertz. So you're getting something close to broadcast AM with around half of the spectrum of single-sideband. And this is the secret sauce behind it. It's what they call an auto-encoder. And I want to briefly just explain what it does. So you have your input layer, which in this case is voice. There is a machine learning section that takes the relevant components of that and compresses it down into what they call a minimal feature set. On the decoding end, the algorithm takes that minimal feature set and attempts to reconstruct the original input. And so you can see there's 3 layers. We have your microphone, that's you talking into it. What's being sent over the air is the compressed representation of the input, and the receiver will decode that and recreate the voice. You need, of course, your transceiver, and you'll also need a computer. Connected to the computer, you'll need a speaker and a microphone. Rather than using the microphone connected to your radio, you'll have to use a microphone connected to your computer because the software will have to encode your voice. It also has to play back the voice through your computer speaker. Oftentimes, you'll find that a headset with a microphone, similar to the ones used on video conferencing and computer gaming, works great for occasions like this. They can be had fairly inexpensively. You can get a decent one for around $40 to $50, even less when there's sales like Prime Day. So for the connections, your radio has to be connected to your computer, of course. If you've done any digital modes like FT8, WinLink, this should already be familiar to you, and you probably already have that set up. You need to connect your speaker and microphone to the computer, and like I said, you won't need to use your radio microphone for this. The setup is very similar to other digital modes. You set your radio, you set your audio input and output, and the first time you start up the program, there is a quick setup screen that has all the options on one panel, just like this. So on these three sections on the top, you have the sound device selection. The first one would be your radio device. And for those of you that have multiple devices connected to your computer, one of the easy ways to figure out which device is your radio is just to unplug your radio and see what's in that list. Make note of what's in that list and plug in your radio. Whatever shows up after you plug in your radio, that's the device you want to select. Then you select your computer's audio input and output. That's how your digital signal will be encoded and decoded. And then step 2 is to select your radio. Of course, you can work it without any cat control, but then you'll have to manually set the frequency and mode on your radio. If you have a radio that's compatible, I'm using a Yaesu FTX1, which the FT991 profile will work with. If you have something like a 7300 or DX10 or a 710, there's already a preset control profile for that. And likewise, you'll have to find which serial port your radio is on. And just like with the audio device, just unplug and plug it in and see what changes. After you're done, you hit the test button. Make sure at this point that your radio is connected to a dummy load or a resonant antenna because it will key up your radio and play a test tone out of it. If your radio keys up and plays the tone, then everything's working fine, and you can go ahead, fill in your call sign, your grid, and hit OK. After that, you'll see a screen like this. How many of you have played with FreeDV? So the first thing you'll do is you'll click on the right-hand side. It'll say Start Modem. You click the button, and you'll see the waterfall start coming down. By default, it starts up in digital mode. So you won't hear any static on your speakers. You really won't hear anything until a valid digital signal comes through. To make things easy, if you want to switch over to analog mode and continue the conversation or just tune around and see what's happening on the band, click Switch to Analog, and you will hear what your radio would normally play out of your computer speakers or your computer headset. When you want to transmit, you can either click the PTT button with your mouse, which is more like a toggle. Click it once, talk. When you're done, click it again. Or you can use the space bar on your computer like a PTT. Hold it down and let go when you're done talking. And so I guess the next part, I'm going to show a quick demonstration of just what FreeDV sounds like and compare against single-sideband. So the FreeDV website has a very good demonstration of how this works. And I'm going to attempt to pull it up here.
You know, there's a couple of things. You do not need to be online for this to work. A lot of people go, oh, it's digital mode. You have to be online for this to work. No. There are some aspects to FreeDV that are enhanced if you go online, like a list of stations that are currently on, what frequency they're on, what band they're on, and what mode they are using. So that's an enhancement, but everything is resident on your own local computer. Now, just something to add, what Jim said, that you need to have a computer. We're getting into a point now with Flex users and Anon users that you do not need a separate computer. It's a waveform that you can put either on a Raspberry Pi that's on the same network, but both developers, Thetis and also Flex, has announced that they are going to build this mode into the radio. So it will just be what mode you want to operate. Upper sideband, lower sideband, FreeDV. And so if you're ready, I probably filled enough time for you there. Okay.
So I like what Brian said. That's the magic of SDR. Certain brands of SDRs, especially those with little built-in microcomputers like the Anon, like the Flex, they'll be able to run this directly on the radio. It'll just be a mode you select. And we're hoping this ends up being on all SDR radios. It's open source. Anyone can implement it royalty-free. So we're about to show what a single sideband signal sounds like. And this is under some pretty bad conditions. And hopefully this plays through the speaker and doesn't blow your ears out. How many of you caught any words in that signal? You can kind of dig it out, but yeah, that's kind of, so that's a, they said it was a 4 dB SNR from Texas to New South Wales, 13,680 kilometers of distance on single-sideband voice. I'm going to play the same signal on FreeDV using the RADE encoder.
K5CJ testing 1, 2, 3, 4, 5, auto encoder. She sells seashells down by the seashore. Testing 1, 2, 3, 4, 5. K5CJ.
Yeah, sounds like a phone call. Now, you may have noticed the little fade where the decoder was corrupted and you heard some complete gibberish. The reason for that is right over here. So, right over here, this signal here is the modem checking the voice band. They call it a chirp, and it's simply the software checking to see whether the frequencies, whether there's any QRM, any stray carriers on band. This is the single-sideband voice signal. And you can see right as they were transmitting digital, there was a bit of QSB, and it faded out and came back in. But the algorithm attempted to decode, it tried its best, and even though you heard some gibberish, it still had the signatures of a human voice. Now here's another one. Here's another interesting one. Here's one from Taiwan to Thailand, using just 100 watts. And here the SNR was a bit better, but look at that digital signal. What does that look like to you? That barber pole pattern. Getting some selective fading here. On single sideband, you would hear phasing, and this is what the single sideband signal sounds like. In a contest, everyone's 5'9", but how many of that? No, here's that same signal.
Secure. Here is the Alpha X-ray for Alpha Charlie Papa. Now I have to speak Chinese. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Those count from 1 to 10 in Chinese. So what this is trying to prove is that the radio encoder, it does not take input, translate it to text, and replay the text. It works with any language, with any voice, and the resulting voice on the other end sounds pretty convincing to the original voice. It's not AI synthesizing speech, it's compressing and decompressing speech. So those last two signals I showed you involved a male voice. And as an SFARC member famously said, a YL voice is 6 dB of gain. And I'll show you what 6 dB of gain sounds like. Here's a little background. Here is a Japan to Japan contact involving a HAMS XYL, around 546 kilometers. The SNR was just 2 dB. And this is what 2 dB sounds like on single sideband. The same signal with FreeDV's RAID mode.
本日は晴天なり。本日は晴天なり。
So now that you've heard it, this is the future of single sideband. There was people claiming that just like how AM gradually took over from CW, just like how single-sideband took over gradually from AM. There's a chance that as the bands get more crowded, as the noise floor gets higher and higher, that this will become the new standard of phone over single-sideband HF radio. And like we said, no internet necessary. It's all running locally on your machine, and maybe even radios in the future will be able to run it directly on board.
Do you have an example of the recorder?
Yeah. So one of the questions a lot of people are going to ask is, how do you get started with FreeDV? Who do you talk to on FreeDV? And there is a section of the website called the FreeDV Reporter. And what that does is it lets you find other hams using FreeDV. If you're connected to the internet while running the application, you can optionally allow the application to publish online what band and frequency you're on, so others trying to make a QSO with you can easily find you. Simply go to qso.freedv.org. It'll list everyone that is on FreeDV right now, whether they're receiving, whether they have whether they have receive only, or whether they're transceive. You can see the frequency, the mode they're using. FreeDV, in addition to RADE, supports some other modes. The previous versions of the application use that, and then RADE is one of the newest modes that's been out, I think, released since September, I believe. Yeah, 2-3 months ago. So this is still in its infancy, and it already sounds this good. Then this is what they call version 1 of the algorithm, and they'll continuously work to improve the algorithm. There are plenty of computer engineers, software engineers, electrical engineers that are working on this code. It's a collaborative effort, and if anyone here is interested, you can simply go to GitHub, find the repository. If you have any background in machine learning and computer engineering, this is for you.
So we all know, or what does it sound when you're tuning around the dial and you hear the digital? We know what FT8 sounds like when you, yep.
Yeah, it kind of sounds like...
Or when, God knows, APRS today, right? We all know
So
what that sounds like.
It sounds almost like a rushing noise, if you will. I've played with FreeDV a couple times. Yeah. It sounds like just a rushing noise, almost like what digital TV sounds like. I guess the modulation looks very random. Based on the modulation, you can't tell the speech that's actually being transmitted.
A question when I'm working with people is this transmitted in the digital portion of the band, the CW digital part, or is this a voice mode? And how do you choose which mode to use?
Yeah, so it's transmitted in the phone portion of the band. It's treated as a voice signal, no different than D star on HF would be transmitted in the phone section.
So Jim, so it works with modern radios. How about like an FT897, which doesn't have a built-in sound card? Do you have to use like a master's communications board, an RA board?
Yeah, if you have an older radio that doesn't have a built-in sound interface, you'll have to use an external sound interface, but it'll work with any single sideband transmitter with a certain amount of frequency stability.
One other thing, do not be tempted if you see other stations using, like these stations down in Australia right now are transmitting below our phone frequency privileges. So don't be tempted to go work them, because it's basically out of our gentleman's agreement portion of the band.
So I guess people often ask me, how do you determine whether it's digital or phone? And it's the end result. Is it meant for a human to decode or a computer to decode? Right? Things like FT8, things like RADE, it's at the final signal in the end is still unintelligible by humans. Whereas things like FreeDV, things like D star and YSF, the end result is a human voice. Therefore, it is a phone mode.
Okay, another question. So, what if there's two digital signals being transmitted on the same band? Will they both come decoded on the other side?
It won't. So unlike single sideband, if two people transmit on top of each other, the decoder, I guess there is no capture effect. It's still single sideband. Yeah. So it's almost similar to FM.
So how does it work with VHF and UHF?
Not available yet, but I mean, FM. If you try to transmit it over FM, you can do it single sideband on 2 meter and 70 centimeter on any other band. But it's designed to be modulated as a single sideband signal.
But it's in development.
They're working on it to work on. Okay. So it's not there yet.
They're working on that.
People are using it. If you look on the chart here, sir, if you don't have a microphone.
Yeah. If you look at the FreeDV reporter, in fact, if you scroll down, you may see people operating on FM. You'll often see activity on 2 meters and 440 out of Europe.
So another cool thing about that website is notice how below all the headers, there's an up and down arrow. You can sort it by things like call sign, by grid, and like I just did, by frequency. So you see the highest frequency that someone's currently transmitting on is on the 6 meter band. And yep, it's John out of Massachusetts with the 101D.
So Jim, on the sound card, on an external sound card, it doesn't matter. You can configure it to any sound card externally.
Yep. So if you're already doing FT8 or VARA or any other digital mode, this would be no different. It just needs a bandwidth around 1.5, 1.6K.
Okay.
Any other questions? Right, see you on the air.
Thank you, Jim. That was a great presentation.